everybody. My name is Andreas Lubeck. I'm from Emetec CTS. I'm the leader of our EMC lab, and I want to show you a quick overview about our demo board. This is a special demo board to show some customers how to use the burst generator, what are effects at EMC tests for immunity, for example. First of all, I want to describe you how to connect this board to the burst generator. For example, here you see the burst generator. Yes, including his output. You have got the EOT adapter, and we put the AC/DC power supply unit for the demo board directly at the output of the burst generator. So the powering of the board is by DC, by a small voltage, so that you simply could touch the DOT. That is not critical, but take care that you do not produce ESD by touching, but it is safe. You have got 4 different input ports. For example, in this moment, edge 4 is active. You see these red bridges. So when I switch to another input port, for example, edge 1, the board is not working because the bridges have to move to this input port. For example, I put it simply on here. 2 bridges, not in that direction. Please do it in this direction, because then you shorten the output of the power supply unit. So you see, it's working. It's a simply demo board where you have got a little bit all-to-digital technique. You could change the lights by changing the program. So maybe you have got other functions by flashing the lights. The red button is a emergency switch, or better to say, when you push it, nothing happened. Yes, it switched off, but when I go away, you hear beep, or maybe the relay will switch, and so on and so on. So this board is not effective, destroyed against disturbances. It should show you disturbances. I want to start with the input edge 4, because that one is the sensitivest one. For example, here I have got the burst generator. I put the positive disturbances on L and N, for example, by 5 kilohertz burst with 200 volt. 200 volts shows you maybe when you see the board first no effects. When you touch, for example, this output port, you see an effect. That is because I produce a capacitive coupling from this port over my hand to the ground plane. In this moment, the disturbances go through the board and will destroy it. For example, when I increase the test level from 200 volt, for example, to 300 volt or 400 volt, you see already an effect. The relay will switching, the LEDs will lights on, and so on. So that is disturbances. When I stop the disturbances, for example, then all is fine. Strongly you could say maybe this is a criterion B, what is passed. But what is the effect when the relay is switching in the real praxis? Maybe that is an emergency switch or whatever. We'll switch the whole electricity off. So it's a big question if this is a performance criterion B or not. When I go on with the disturbance, for example, again I have got an influencing product. I stay with the disturbances at 400 volt and I switch it, for example, to edge 3. At this input, you have got a little bit more suppression. That's not a varistor, that's a capacitive. And this capacitive takes the disturbances to the grounding of the board. Nothing has happened. When I increase the level, for example, to 500 volt, you see, nothing has happened. When I switch it to 600 volt, there you see already effects by the LEDs. 700 volt, 800 volt. I simply increase the level. You see, more influencing, more influencing. And suddenly at 1000 volt, also the relay will switch. Now I go to the next board. There, the effectives of the capacitors, not varistors, capacitors are more effective. You see, again, no disturbances. For example, when I disconnect the earth of the PCB, maybe in this moment you see the LEDs are flashing, there is an influencing. When I go back to grounding, it works fine on. Or for example, I simply put a cable on one of this passive RS232 connectors, then you have got an influencing. I put it away, then it's fine. It is the same like the effects, what is when I push or touch this one. When I go to this one, you have got not a big effect, because here the suppression for this output is better. And so on and so on. And if you go to the last one, edge 1, it is more effective. So for example, I go on with my test level, for example, to 1500 volt. In this moment, it works very fine. But if I put my hand close to the PCB, you see effects. For example, simply put only the finger for that, then you see effects. Put the finger on that, you see effects. So, sure, that is EMC, because maybe this suppression is not good enough. Again, I have got 1500 volt. When I disconnect the grounding, in this moment it works. Yes. If I go to 2000 volt, it works also on. When I disconnect in this moment, that connector, it works also on. And you could go on and on and on. For example, 2500 volt. Here you have got already effects. Maybe I'm not sure what is happening when I ground my board. The beep is not coming, but the LED is flashing. So that's some effect of this board. So again, I will stop the disturbances. Please power the board with the DC power, with that power supply unit. Take care to ground the board. That is, let's say, the ground plane. If you have got not the test bench with the ground plane, then simply use this one on the new normal table. Connect this one to the test generator. In this moment, for example, over a connector in this way, simply to ground of the test generator, and then do the test. That could be also a way when you have got not a whole test set up. Okay, just have got enough fun. Good luck for testing, but take care. Do not apply directly SD to the board. Then we have got the damaged device. Thanks, bye.